Okay, just going to go through question 3 from exercise 10F, which is on page 176. We've got two particles, A and B, with a mass of m kilograms and 3 kilograms respectively. M is bigger than 3. In other words, m is going to fall down and b is going to be pulled up. The particles are connected by a light inextensible string which passes over a smooth fixed pulley. A is initially 2.5 meters above the horizontal ground. The particles are released from rest with the string taut and the hanging part of the string vertical as shown. After A has been descending for 1.25 seconds, it strikes the ground. So T equals 1.25 seconds. And particle A reaches the ground before B has reached the pulley. So this will hit the ground before this hits the pulley. It's to show that the acceleration of B as it descends is 3.2 meters per second squared. So the acceleration of B ascending will be the same as the acceleration of A descending. So part A, you could do forces, but there's not enough information for this, unfortunately, so you're going to have to use SUVAT. And we're using SUVAT on particle A. It needs to fall 2.5 meters over 1.25 seconds. Initially is at rest, and you want to find the acceleration. So you've got S equals ut plus a half at squared. S is 2.5, u is 0, 1.25s plus a half a 1.25 squared. And if you make A the subject, 2.5 divided by half 1.25 squareds, get 3.2 as required. Okay, part B, find the tension in the string as A descends. So this one, you now need to consider the forces. So let's consider the forces acting on effectively the particle with the most amount of information. So particle B, you know the mass, particle A you don't, so I'm going to focus on B. Resolve B only. Forces acting on B, it's attached to a string, so there's going to be tension, thing you want to work out. Has a mass, so there's going to be a weight, 3g newtons, and that is it. And it is accelerating. So F equals ma, Newton's second law. The mass of this object is 3. The acceleration of this object is 3.2, we just worked it out. The resultant forces going with the motion, subtract going against. And if you make T the subject, 3.2s plus 9.8s is 39. And that'll be the same as the tension acting on A. Show that the mass of A is 65 over 11. This is part C. So this time we're going to resolve A only. So the forces acting on A, well, it has a weight, mg. It's attached to a string, so there's going to be tension, T newtons. And that is it. And it is accelerating. So F equals ma. The mass of this object is m. The acceleration of this object is 3.2. The resultant force is going with the motion. Subtract the forces going against the motion, which is T. But we now know what T is 39. So mg subtract 39 equals 3.2 m. If you take the 39 to the other side, and remember this is 9.8 m. 9.8. So 9.8 subtract 3.2 gives you 6 0.6 m. And if you make m the subject, 39 divided by 6.6 is the 65/11 as required. Part D, show how you've used the information that the string is inextensible. So the modelling assumption for inextensible means the acceleration is going to be constant. So the acceleration for both particles is the same. Okay, now this last part, but when A strikes the ground, so A is eventually going to strike the ground, it does not rebound and the string becomes slack, so the tension is removed. Particle B then moves freely under gravity without reaching the pulley until the string becomes taut again. Find the time between the instant when A strikes the ground and the instant when the string becomes taut again. Okay, so one of the most common things with this type of question is you want to know the speed or the velocity that A hits the ground, and then that gives you the velocity the other particle's going up in. So the first thing I'm going to do is work out that final velocity, so do that. So the displacement is 2.5, initially it's at 0, final velocity is the thing I want to work out, acceleration is still 3.2, and the time is unknown. And we want the time between the instant when A strikes the ground. Okay, so we don't care at the time yet anyway. So v squared equals u squared plus 2as. V squared equals 0 squared plus 2, 3.2, 2.5s. If you square root all of that, 2 3.2s times 2.5, square root the answer is 4. So the speed that A hits the ground is 4 meters per second. In other words, the speed that B has when the string is about to become slack is 4 meters per second. Now, this is the difficult bit. So the string is now slack. And if you do solve that for when the string is slack, let's do the easy bit. So its initial velocity is 4. It's going 4 upwards. You want to find out when it's going to become taut again, which would be effectively when it returns to its same position. So if you think about it, B is going to go up, then A is going to hit the ground. It's going to keep going up a little bit and then come back down. When it comes back down, that point will be when the string becomes taut again. So relative to that, S is 0. Final velocity, don't know, and because it's the string is now slack, minus 9.8, T is the thing you want to work out. So you got S, U, A, and T. S is 0. T squared, and you've got a quadratic. So 0 equals 4t minus 4.9t squared. And you can actually factorize this immediately. To give you 2 times, either t is 0 or t is equal to 4 divided by 4.9, whatever that is. .816 seconds. So that'll be the time it takes B to go, once the string has become slack, go up and then back down to its same position, therefore the time when the string becomes taut again.